We're going to talk about how to find the right and left end behaviors of different polynomials. And what I have right here, I'm going to go through 3 different examples of how to explain and how to determine this. The key thing is when you find right and left end behaviors, is that a right and left end behavior is talking about what is happening as x, oh man, I should say it this way. For a right end behavior, you're trying to figure out what y values, where are the y values going as x goes to infinity. Okay? When you're talking about, so what are the y values? All right, what y values? What are they approaching as x goes to infinity? When you talk about left end behaviors, we're talking about what is the x value, what happens to the y values as x goes to negative infinity. Now, for different functions, their end behaviors do different things. With polynomials, it's pretty straightforward. When you have an odd degree polynomial, okay, an odd degree polynomial, like what we have right here, we have x to the 5th degree, which is an odd degree polynomial. All right, an odd degree polynomial has x values as x goes to positive infinity. All right, the y values will increase, okay, or they will rise. So it also, the y values are going to be approaching positive infinity as well. As x goes to negative infinity, the y values will fall. A lot of books call it they will fall. That means they're going to go to negative infinity. So as you go in different directions, they're going to rise and fall. Now, to help us figure this out, what we can do is we can look at this graph. We can graph this on a graphing calculator. So if you take this out, all right, take out your graphing calculator, and you can graph this out, and we can punch in, when we look at here, and go to our y equals. All right, clear that. And we have 2x to the 5th. All right, and we're going to have minus x, or 5x, and then we're going to have plus 7.5. Okay, when we graph this, what you see, all right, as we go to infinity, and I'm going to go zoom 6 real quick. And there we go. Okay. Now, when we have this, what's going to happen is this is graphing. And as we can see, what this is going to look like, all right, is what we have just as I stated before. All right. As x goes to, as we plug in values going to negative infinity, as x goes to negative infinity, you notice that the y values are going down. All right. Y values are falling. So that's what's telling right here. All right. This is known as a left end behavior. End behavior, EB, I'll call it. Now to the right, just in green, you can see as we go to the right, as x goes to infinity, all right, you can see that the values are increasing, and they keep on going higher and higher. So our y values are then going to positive infinity, all right, or rising. So that is what's happening with end behaviors. So when you're determining the right and left end behavior, you look at the degrees. So all odd degrees, all right, have left end behavior or right end behaviors that rise and left end behaviors that fall. Okay. Now, a little bit different is when you have something, when you have a, all right, an even polynomial. When you have an even polynomial like this one right here, okay, it's going to change a little bit. All right. And what's going to happen is as we have this even polynomial, what's going to happen is with an even degree is that as x goes to infinity, you'll realize that the y values will also rise and will approach positive infinity as well. Okay? When x goes to negative infinity, what will happen is that the y values will rise again, all right, and are approaching infinity as well with that. And the reason why is because the x to the 4th takes the values and makes all the values positive, all right, where a negative degree, as we have up here, all right, when you play negative values, all right, makes the values negative. Okay, so when we have that, and that would be our left and right end behaviors here. This is our right end behavior, and this is our left end behavior. And we can once again look at this on our graphs. If you graph this out, you would notice, and we'll do that right now, if we take this one right here, and I go to my y equals, and I'm going to graph this one, we have, put in parentheses, 3x to the 4th, and we'll have minus 2x, and we'll have plus 5. And what will happen, we'll divide that by 4. And when we graph this, is we'll notice to the right, okay, that our graph is going to go rising, and to the left is going to also rise, just as we stated right here. Okay, and we can see that as well. I'll just take this one, put it over, and you can see that this graph right here rises to the right, goes to infinity to the right as x goes to infinity. Goes to infinity, it goes up. As x goes to negative infinity, the graph also goes up, so they both rise. Now, one more example that we have here is what happens when we have a graph that looks like this. If we have this right here, we look at our powers once again, and we see we have a cube. So knowing that it's an odd degree, it has the odd degree properties. Okay, odd degree. All right, the right end behavior, EB, as x goes to infinity, that means our y values are going to also rise. Now, there's one thing that we might want to just take a look at, is that this is a little bit different because notice how we have a leading coefficient. All right, and our leading coefficient in this case is negative. All right, now, since we have a leading coefficient that is negative, leading coefficient, which is negative, all right, that negatives mean a reflection. So instead of having, when x goes to infinity, instead of having it rise, this reflection is actually going to make it fall. It's going to go in the opposite direction. All right, everything is opposite. Okay, so that means it's going to fall, and then it's approaching negative infinity. In the same way as it goes to negative infinity, as x goes to negative infinity, originally it would fall, but in this case it's going to rise. Okay, because as we plug in negative values, it's going to stay negative, but a negative times a negative is a positive. All right, because we plug in that negative number times a negative number is a positive number. We're talking about really big ones. As we plug those in there, and that's going to rise. And we can just verify this on our calculators, just describing this, and we'll punch this in. So we'll clear that, and we put in negative 7/8. And we'll put in our parentheses. We'll just use x to the third. We don't have an s, and we have plus 5 s squared. Oops, back over there. Plus 5x squared. And then we'll go minus 7x plus 1. And we'll graph that. And you should see, once again, all right, rising to the left, all right, and falling to the right. All right, rises to the left, so my left end behavior rises as x goes to negative infinity, and it falls to the right as x goes to positive infinity. All right, so it's falling and rising. All right, and those are the end behavior. End behaviors are what happen as x goes to infinity or negative infinity. That's the key thing. All right, and with odd ones, all right, they have this property. The right always rises and left falls. All right, even, they always going to go to the right is going to rise and the left is going to rise. When you have a reflection, everything in each case is going to be flipped, or the opposite of what it originally was. All right, that's what's called the leading coefficient test. All right, in identifying end behaviors and whether they're going to rise or fall. Hopefully this helps out. Good luck, and God bless.